All right, so I'm looking at activity 2.1.1, the distance learning section. And I'm down at number 7, and it shows how they've investigated the hole. You're supposed to measure it. They give you the data, so you have that available. And what I did is I took the data and I put it into a Google document. Okay, I've shared this with you all in your folder. If you go to File and you click on Make a Copy, then you will have an editable copy. Before, if you were trying to use mine, I have it locked so that you're just viewing only. So again, File, Make a Copy. Okay, and it'll pop up a piece like this. All the measurements are already in there, so you're ready to go. The first thing it asks you to do is to calculate the mean and the standard deviation. If you're not sure what mean or standard deviation is, mean is just the average. So you're taking all your numbers and you're adding them together and you're dividing by the total number of pieces of data you have. So thankfully we're going to use Excel or Google Sheets to kind of help with that, just to be quicker. So equals average, close your parentheses, and then we're going to go pick our column. Okay, so we got our average size is 2.23642. All right, then the next thing it asks you on your distance learning is to find the standard deviation. If I click on standard deviation, it's going to take me to a whole lesson about standard deviation. So for those of you who maybe aren't as familiar with the statistics or haven't worked with that as much, this is a great tool for you and for your students. So you can click on standard deviation. It's going to explain what it is. It's really just talking about how close is your data to the mean. Mean, again, is the same as average. So if you look at this, like A, your standard deviation, if you look at it, it says this graph shows the data it has a mean or a standard deviation of 1, meaning most of their data are really, really, really close to each other. Okay, I can fit most of it right here. If you notice on the second one, B, my data kind of like flows out a little bit. So I'm not as close to the center for all of these, so my standard deviation ends up being a little bit larger, or it has a standard deviation of 2. And that's how far away it is from the mean. Okay. So there are 2 types of standard deviation that we create. You have population data, and this is going to give you the formula. It looks really scary to a lot of students, but really you're just taking the mean and you are subtracting each of the pieces of data, subtracting the mean from it, you square it, and then you're taking all those pieces of data, you're adding them together, which is what the sum part is, and you're dividing it by how many pieces of data you have. So like this one has 20 pieces of data, so this would be 20. You can definitely do this by hand. Like I said, you just take each number, subtract the mean. So like let's say for instance, I was taking the first one, be 0.2338, and I'm going to subtract 0.23642. And then once I get that number, I'm going to square it. I'm going to like save that number to the side. Now, I can definitely do this with Excel if I wanted to. I could go in and create a piece where we take the formula would be equals piece of data. Should probably put a parentheses there. And I subtract the mean. That's our average number down here. Close my parentheses, and we're going to square that piece of data. Alright, so like I said, we took your piece of data, subtracted your mean, and then we square that. So I'm going to repeat that again. My piece of data, subtract my mean, close my parentheses, and we're going to square it. Alright, now that I've got a couple of these set up, I should be able to highlight and drag. For some reason, the second ones are not grabbing that formula correctly. So I need to continue to grab the one below it. So we're just going to take this. Play nice. Nope. Alright. I'm going to adjust this. See if now it'll recognize it. Nope. Not sure why. Anyways, it's supposed to say this time. Alright, so if I look down here, I made a couple of things, so sum and standard deviation. So I'm going to type in sum here, equals sum. Get this whole column. Parentheses. And now standard deviation, the formula is square root of the sum divided by the total piece of data. So I'm going to divide by 20, because we have 20 pieces of data. And that gives me my standard deviation is 0.0016. So my mean is 0.236. So that means about, when you think about standard deviation, about 66% of your data is going to fit within one standard deviation. So plus 0.0016 and minus 0.0016. Now, there's a quicker way to do standard deviation for sure. I also could have used the formula equals, and we can do standard deviation population or standard deviation sample. And so I'm really taking a sample of this if we're going to be honest about it. So we try to use the sample data. So I'm going to click on the sample, and I can go up here to my measurements again, and I can click on this and get that data. So that's the easy way to do it, for sure. And notice it's a little bit different. I calculated using population, meaning that I'm taking everybody into consideration. This is standard deviation with a data. Okay. The next step it asks you to do is to construct a dot plot or a histogram of the corner block of the whole. And so this is to kind of show you what a visualization of that looks like. They give you some information about what a dot plot is. So on number 7, the last part is C. I want you to make a histogram. Just pretty easy to do. You just basically start with your lowest number, go to your highest number. They kind of give you an example here. And then you mark how many times that number appears. It may just be all over the place in this case, just because of what you're dealing with, and then you draw a line showing you where your mean is. Part 8, which is part of your submission form, you're going to take your standard deviation and your mean, and you're going to find out what is it going to give you 99%. So that means plus or minus 3 standard deviations. So if I go here to my piece, my average or my mean was 0.263642. So my minimum would be if I take that 0.632642 and I subtract, I'm going to use my sample one, 3 times. And we could do better math and do minus 3 times that. That's fine also. But so this is my minimum, maximum. We're going to do the same thing, except for instead of subtracting 3 times, we're going to add 3 times. Now you can definitely do this by hand. I'm just showing you how you can do it on Excel. All right. And so this shows you my minimum tolerance should be 0.231 and my maximum tolerance should be 0.241. And so that's kind of how you do that part for A. And then B says, use the mean and standard deviation that you just estimated to look at your work from above and decide, would yours fit inside this? So whatever you made tolerance for your rod, would it actually fit in those sides? And then through here, you're going to be working on the observation. They've got a little video. Work through that. And kind of summarizing what you've learned and what you think about it. And you can discuss this with your teammates. This is why we kind of want you guys to work together. And then we have 3 different types of fit. We have what's called a clearance fit, where it limits the size of the mating parts so that the clearance or space always results when mating. So think of something you want to always fit inside. Okay. That's a clearance fit. An interference fit is it's fastening between 2 parts, which is achieved by friction after the parts are pushed together. So rather than any other means of fastening. So I was thinking about like those little pegs maybe when you're building a bookshelf that you're putting together. They'll fit, but it's definitely like a tight, you can't like pull it back out really after you get it in there. And then transition fit occurs when 2 mating parts can sometimes have a clearance fit and then sometimes they don't have a clearance fit. I think of the little push pins that you can put in and then they open back up so that they'll fit. So they kind of give you some examples of what this looks like and how you can describe it. Anyways, there's your dowel rod. Give you some examples. Talking about allowance, what are those conditions allowing? And then we get down to number 11. It says investigate the drawing. It says what type of fit is shown here, justify your answer. What is the tolerance for the shaft diameter? What is the tolerance for the hole diameter? So when you're looking at your tolerance here, you're just taking your subtraction between the 2. And the same thing here. And this would be your hole. This is your dowel that's fitting inside it. And that's pretty much what you're working through. So hopefully that gives you a little help with the Excel sheet part, and you guys should be good. Have a great day.